turn the headstock freely, but turn the tailstock freely, but the headstock is running with 0.9 horsepower motor with geared advantage. So it's a lot too strong for a lathe, and I'm like afraid of letting other people work on it, because it will like rip out your arm and beat you to death with it. Probably it's as strong as a metalworking lathe on the left side. The right side is clutched with an electromagnetic clutch, so it's safer. So, then the next thing, it's gonna be a bit random. Yeah, one of the tasks we carry out is encapsulating radioactive samples. Here is one double quartz in the process of double quartz vacuum encapsulation, where you have a dedicated glove box for that purpose, with a small torch, like a mini torch. Klaus would probably know what I'm talking about, because it's a German make torch. Large cumbersome leaded rubber gloves and a pane of leaded glass, slightly brownish, in front of you, and you need to like seal those. Seal those in glass or quartz. I also do neon. Work. It's like the German style. It's not the usual smooth and round bending. It's well welded out of sections of boro, and the interesting thing about it is that it's phosphor coated with a phosphor that was developed in the institute from raw materials, and this one is called non-fading green, because if you're familiar with the triphosphor phosphor coating system, the typical green phosphor will fade out prematurely, leaving us with lamps that glow like pink, magenta, and this one doesn't do that. So that's being currently patented. But they let me use a sample to powder coat their logo. Instytut Niskich Temperatur i Badań Strukturalnych Polskiej Akademii Nauk. Yeah, that's what it sounds in Polish. Here's me making fun of a bioreactor. It's a borosilicate jacketed, partially jacketed reactor, which I made for growing genetically modified algae and yeast, used as functional supplements in horse feed. So one team was researching that, and they made me make a reactor like that. I typically have to use, unfortunately, Chinese boro. It's a pain to work with, because when you get a case of it, especially the large diameters, when you take them out of the box, the ends are like cracked off, not melted in. So you need to lose like 5 centimeters of each end. And to be able to just saw them off and clean up the ends, you have to anneal the whole tube, because they come in strained. And the strain is so great that you can see thin yellow streaks under the polariscope down the whole length of this tubing. I don't recommend using it if you don't have to. And I have to pre-anneal it to be able to chuck up to it and to be able to use it. The other thing is that it tends to be out of roundness, like by a quarter of an inch even. So it's like an egg shape. The large diameters are egg shaped, so it makes it difficult to chuck up. And you need to like put additional piece of lathe tape here and lathe tape there, until you're able to spin it up, heat it up, and resize and reform it a little bit so you can work with it. But that's typically what the customers want, because large diameters of glass made by Schott are either almost unavailable. They're made in production runs, and the Germans make some diameters of tubing 1/4, other diameters other quarter, and if they are not stocked up with certain diameter, you have to wait like a quarter or half a year for a specific diameter. So we typically end up using Chinese, which is readily available. I hate working with it. Both the glass and the flanges, everything except for the pink and white hose barbed things and the valves are made in shop, in my shop by me. The flange is CNC routed by me, and the molded stainless steel nuts and the stirrer rod with the stirrer rings, the Teflon joint through which the stirrer rod protrudes also is made in the shop. So I'm like both glass blower and kind of a fabricator. I have to be. Oh, that's the next interesting thing. That was a DWAR vessel, like 4-volt DWAR vessel, like a vacuum jacket, space for liquid nitrogen, so you can have a liquid nitrogen mantle, then another vacuum jacket, and then the main cavity for liquid helium. It was built for the purpose of testing austenitic steel samples, like stainless steel samples, for their tensile strength and the material flow in the temperature of liquid helium. The samples, here we can see a titanium rod which goes down into the helium bath, and we have like two titanium vices which grab onto a substantial sample of stainless, like 1/4 inch by, I don't know, 3/16. I don't do imperial. Very, very good. And this titanium arm let their researchers put it in a strength testing machine and transfer the force down into the helium bath to like pull on the sample. The sample needed to be coated with a special paint containing like very, very bright, like bright particles, and the DWAR needed to be executed with transparent stripe through all through the silvering of all the layers. So you could direct lights and cameras at the sample while it's being torn apart in the liquid helium. Why would you need to do such a thing? It's a part of space exploration studies. It was for so-called susceptive mechanisms, like mechanisms that have a lot of axes of movement, a lot of levels of freedom, without having moving parts, without having hinges, without having anything like that. Because if you make a hinge out of, like, both parts of the hinge are of the same material, and it's made very precisely, and it's a snug fit, it will gall and weld together in vacuum of space. So it is best to have like the small ionic thrusters or rocket engine yokes in a sort of a susceptible basket without hinges and without anything like that. So the scientists needed such a piece of apparatus to test austenitic steel and how much you can strain and force it, how it will flow. Oh, Here's probably one of the most complicated glass to metal seals I've ever made. It's a ordinary housekeeper on the bottom and some double molybdenum ferrules just under the ground joint. I've made about a dozen of those, which ended up in the bin before I managed to make one that was usable. It was quite a journey, quite complicated. The whole thing is made out of molybdenum glass, and both the ferrules and the larger tube on the bottom is molybdenum. The whole body of it is molybdenum, so I don't have to make graded seals, because I didn't have space for graded seals in that ring of small ferrules, so I chose to make the whole piece out of the matching glass, because it connected to the rest of the apparatus via the molybdenum ring and the ground joint, so there were no other compatibility issues with it. We also make museum exhibit sized demonstrators of physical experiments. Here's a Crookes paddle wheel tube that we made for one museum. Oh, here's another one. There was a lot of them. Kamila here made the rod work, the glass rod work in this one, and I made the axes, welded the stainless steel forks to it, and added the mica veins, routed and added the mica veins and micro welded it. In my country, a glass blower needs to be also a fabricator. Now here's another view of it. Oh, here's another example of a museum-sized piece. It's an electron beam tube where kids at the museum will be able to move the stream of electrodes around by moving a large neodymium magnet over it. And there's a stripe of phlogopite mica down the length of the tube, and it's phosphor coated, so it would be better visible. I'll get to the coating later. The presentation is like a bunch of photos that we slapped together without a chronological order, so it's gonna be random. Here's another piece. Because one of my specialties is filling plasma sculptures and plasma apparatus. This one was made to mimic the colorful gas discharges in aurora on different levels of atmosphere. We actually had to cheat a little bit with this one, because the typical, it's an enlarged version of Geisler-Plicker tubes, but typically Geisler-Plicker tubes are made with a heavy-walled capillary, and we get a very strong condensed discharge. And here it wouldn't work so well. I've been trying to figure it out for a while, and it came out that in the small tubes there would be a lot of secondary electron emission from the surface of the glass. So the gas discharge was of a different color and brighter than we could achieve in those 110 millimeter, almost 2 meter long tubes. We tried filling them with atmospheric air, just ambient from the workshop. That didn't work out very well. Then we had synthetic air in small lecture bottles made for us and shipped in, and we tried that. The air was of the exact same composition as you would encounter on the poles. but that also didn't work out. So I ended up cheating a little bit and adding dashes of adding a little bit of noble gases to achieve, let's say, those Faraday dark spaces and other kinds of discharge. Oh yeah, joking about glass to metal seals. I'm a self-taught glass blower. There are no glass blowing schools whatsoever in my country. So I had to learn everything myself, or by picking the minds of American glass blowers, like writing to Mike Souza or to Bruce Suba or Kevin T or Mr. Kevin T Ford, and picking their minds or calling them and asking them questions. So I'm very grateful to the American scientific glass blowing community, because like, you guys made me what I am as a glass blower, virtually. That was quite adventure, making glass, learning how to make glass to metal seals. First I needed to order uranium corning, which gave us some problems at the customs. And then I've spent, I don't know, about like over a week trying to get that to stick, trying to learn how to prepare the metal, to get the oxide layer just right. I've come to the point where I wanted to take a shard of glass from the bin, like open my veins and say, like, let's end it here. I'm not gonna do it. But here I am, overcome that problem. Now here's a picture of the base portion, the seal portion of like 160 liter plasma globe, originally made by Wayne Stratman. That was made for the EC1 Experiment Center in my city, and an Estonian company that was putting it on its pedestal broke off, like cracked the seal and broke out the pump down tube, turned around and left. Oh, it's nothing, it's just a small portion of glass. Probably doesn't matter. So
clean the floor.
Yeah, we found it on the floor. So I have to. There's gonna be a lot more pictures from that process further down. Yeah, here's the plasma globe set up on a movable cart bottom of the furnace. We have to redo the furnace to be able to bring the whole bottom out and put the globe on it. And we hooked it up to a bombarding station. This is a bombarding station that I made. It weighs like 2 tons, and we had to ask all the neighbors for help so we could push the kiln body and the bombarder ever so slowly, because it was connected without any bellows or without any section of Viton tubing, just with a section of 16 mil mid-wall tubing straight to the pumping station. So we had to like move it super carefully and super slowly. Yeah, here I am, like testing it out, pouring light into the void, filling it up with some neon. We also do artistic work, like commissioned artistic work. That was a birch tree, which, if you ask me, ended up looking like a mural. But that's what the artist wanted. Yeah, so like birch tree. Camila made the branches, and I encased it in a large bubble. It ended up filled with like pink liquid. before switching over to full-time glass blowing, I used to be a rope access technician and an arborist for over a decade. I used to work in Germany, like for about 5 years. I worked in Germany in the Düsseldorf, like Nordrhein-Westfalen region. Klaus knows where it is. And one day I've been sitting like after work, having a beer and like, looking for stuff on my computer, and I thought like, no, this was the last winter that I've been working outside, like on a like 200-meter smokestack with fine snow peeling the skin off my face. I said, no, enough of that. So I decided to come back to Poland, and I actually, when I was working in Germany, the company provided everything for me, so I was able to save up what I was earning. I was able to get in touch with a team of our passionate people, and we opened a fabrication laboratory, a fab lab space, a maker space, accredited by MIT. We were actually in the fab lab network. Yeah, here's Camila on the right. She was blonde then. And that's where I met Camila. That's where I met my partner. Okay. Camila came in the shop into the fab lab after receiving some funding from the state to open her own flame working workshop, and she's being told that she could have her space. She could set up her workshop at a place called the Art Incubator. But when she actually arrived there and told the administration what she was intending to do, they said, no, you can like set up a photo studio, or I don't know, sew something, or set up some computers or paint, but no open flame, no gas cylinders, we're gonna die, no, get out of here. She didn't know what to do with herself, and kept searching for a suitable space to set up her workshop, and ended up at our fab lab, where I just cleaned up one corner and set her glass jewelry making and bead making shop. And she started after a while. She started feeding me, and that's
all it takes.
Yeah. I in turn wanted to do something for Camila, who wanted to be a neon bender at that point. I couldn't find. I'm typically able to find any piece of used equipment on the internet, but I've been unable to find a Voltark hide ribbon at that time. So I ended up milling the innards of the ribbon burner out of, it's like it's called styrodur in our country. It's like a polystyrene foam, insulating foam. Gluing it together, covering it in a refractory slurry, putting it in a box of sand, and building a kiln specially to melt like over 100 pounds of aluminum, like glowing hot aluminum, and cast the torch. How's that for a pickup line? Oh yeah, here's our first workshop. It looked nasty. I ended up sandblasting the whole place. It was like I needed to. I've ripped out everything, the windows, the floors, the partitions, like everything. At one point, Camila needed to duct tape floodlights to my head. So here's me tearing down the wall. so I'd be able to see in that cloud of dust. Yeah, here's me after like after like 30 hours, over 30 hours, continuously painting my shop with like a spray gun, spray painting it. Yeah, here I'm welding some equipment, welding a welding table. I've like fabricated each piece of equipment in my shop. So I had some funding, but not enough to have the real guy do it, so I ended up doing everything myself. Here I am putting in ventilation. I ended up pouring the floors and painting them with resin, painting the whole place, putting in ventilation, oxygen piping, compressed air, propane, and everything by myself. Here's my doggo and the neon bombarding station that I have built out of repurposed vacuum components. Yeah, here's how it's going. A lot of gases on that thing. Here's me pumping down the first ever neon tube that we've been able to hook up to the manifold. Like, we didn't know anything. We needed to learn everything and build everything from scratch. And that was a meaningful moment when it came out red for the first time. Because if you guys pump neon with Amy, you know that neon doesn't come out red always. Here's pudding. That's my 95 pounds of fur producing love. He's like a kitchen disposal unit with paws and a heart of gold. He'll eat just about anything. He'll eat raw ginger, like chili and stuff, like brain the size of a walnut. To później, tak? Tam masz tą drugą prezentację, a potem wrócimy do ampuły.
Trwało wiecznie.
Nie będzie trwało. So I know you have the practical part at the torch stations at the lace. How much time have we got? Because there's another presentation that.
Oh, you have as much time as you want. I'm sorry. I'm like, are you? Yeah, no, as much time as you want. It's like,
Said me.
The blue lane, is that the one you have like in your shop, or what is that blue lane that you were working on? Like
that's the lathe I currently have at the institute. I had my boss give me some funding, and we needed to like take the institute's lorry and another car, take two colleagues with me, drive to Germany to a place called Magic Glass, ran by Mr. Thorsten Fröhlich. It was the first shop in Germany that made bongs ever, and he sold me that lathe. I needed to disassemble it in his workshop because he had it put in with a forklift, and then he put up a new wall, so you couldn't just take it out the original way. We had to disassemble it, with a workshop crane that we brought with us and put it on the truck and drive back to Poland and reassemble it. I ended up like taking apart and reassembling and restoring, I don't know, about five or six lathes now. So yeah, that's a lot. Yeah, that's that's our router built by us. Her name is Bożena.
Beautiful.
That was at the Fab Lab. That was at the Fab Lab place. Here's our fab space. Yeah, some kinematic horse or some contraption. Here's our electronics guy. When we had Trotec give us an engraving laser, we couldn't pull him off the machine. He was stuck to it, so happy. Here's Camila's corner that I arranged when she came in our fab space. Yeah, our doggo. The day we picked him up from the city pound. Yeah, more of the sandblasting outfit. Yeah, I couldn't see anything, so they needed to slap that floodlight on my head. And that's my business partner on the left. Yeah, there's that again. Putting in windows in the between the production and the office space. I ended up, I'm a workaholic, and at that time I ended up working myself nearly to death. I ended up at the hospital, like 20-hour shifts and 4 hours of sleep, sleep and eat. I've lost like 20 pounds, about 20 pounds at that time. Yeah, so here's me sleeping like a homeless dude on some stairs. Yeah, welding up. Oh, that was fun. When I eventually managed to purchase an original ribbon burner, I don't know if you've noticed that, but this one is actually equipped with a oxygen valve on the other side. If you ever buy one of those, don't hook it up to oxygen. Like, I can still hear the bang and I can still see the flash. It was like tattooed on my retina. It went boom, and the bolts holding the orifice plate sheared a little bit. So don't add oxygen to water hide ribbons. Yeah, here's another lathe. This one we brought from England. We also needed to drive down there and disassemble it and put it in our car and drive back to Poland and reassemble. So another Heathway, and yeah, here's us working on Hans von Mangold's power controls for the Bombarder. The Bombarders in my country are kind of different from what you guys are using here, because the Willock and Hyde and such typically, or the pole hogs, repurposed pole hogs, tend to be midpoint grounded, and in a midpoint grounded transformer, bombarding transformer, you get all of the voltage and all of the potential between any of the leads and anything that's grounded, and that's quite scary. And in those, they're like polygap construction, so they are like floating, they're insulated. You get the maximum potential only between the leads. So to get killed, you would need like to grab both of the leads. If you grab one, well, you'll get a bad shot, but you'll probably wake up in the hospital. Oh, here's a funny situation. We were putting in a fireproof cabinet, like a very heavy, duper tall, insulated fireproof cabinet for the oxygen cylinders, and it dropped on my business partner. He was trapped under there. We had the whole situation on CCTV. Like in shock, I like lifted this heavy cabinet enough so that he could crawl out, but he erased that. He was too embarrassed. Yeah, here's another heaveweight of the vertical one. I don't know if you have any vertical tilting lathes now.
No, we
They
don't.
are super useful when you make, for instance, glass to metal seals with problematic glasses, like with aluminosilicate, which if you're doing horizontally, it will probably bunch up and tear up and end up a huge mess. And if you can tilt the lathe bed upwards and do it vertically, you can control the wetting angle a lot better, and they end up fine. The seals end up fine. Yeah, here's more. You guys would go crazy if you knew how cheap those lathes are going in Europe. Like we bought the tilting heaveweight for like $2,500.
What?
Yeah, sweet. Yeah, we're putting the big one in the building.
Piece by piece.
Putting the big one in the building, like we needed to move it down a narrow corridor with a bunch of steps. That was quite an excursion. Here's the heaveweight. Another thing in Poland is that you actually don't have any manufacturers of glass blowing equipment. There is none. You can buy some like welding torches and repurpose them, but if you need something more specific, like along the lines of the multi-port Nortel, something with a thin curtain of fire to do like fire cuts and large seals, you need to like fabricate your own torch. And here I ended up taking two torch nozzles originally intended for flaming granite, like when you put some water on polished granite and touch it with a flame so it spalls, like revealing a raw surface. So I ended up taking some swage lock connections and some tubing, and had to fabricate a torch like that. Oh, seeing that, some more of the workshop, a lot of gases on that manifold. I also had to build kilns for those long tubes, long Aurora tubes. I ended up fabricating a kiln out of fiberboard and some steel square tubing. So I could process large pieces of glass and anneal large pieces of glass. It was like, I don't know, 3 meters long inside. Yeah, here's me at my favorite lathe, heaveweight with chucks on both sides of both stocks. It was very useful because, like, if you wanted to make a divorce or something along those lines, you didn't have to wrap it in cardboard or lathe tape. You could just chuck up a longer portion of tubing in the outer chuck and the larger, shorter one in the inner, and go shape the edge. Okay. Yeah, here's some more of it. I welded up the fume hoods and made the manifold, the gas manifolds and the oxygen manifolds out of repurposed hospital grade oxygen manifolds. Like everything was. I had some funding, but not enough to buy the original stuff, to have the original stuff shipped in, or to have the real guy do it. So I ended up doing everything by myself. Yeah, here I'm welding something up. There's another photo. Oh, the interesting thing about that furnace is that I didn't use like Cantle, super Cantle, like resistance spiral heating elements. I've used very long halogen infrared lamps for that purpose. Make it go as high as 900 degrees Celsius. I'd probably be able to go to like 1200, but I didn't. It would be harsh on the connections. Well, I made it like from automatic lid. Here it is without the skin. It got colored in like in sheet metal. Yeah, but that one was sweet. Here's some filling of plasma tubes as per the client's needs. Oh, this one was fun. This one was like high pressure argon, driven by you normally won't light up argon like that, but this was driven with a low frequency, very high voltage power supply. So the streamers were like slapping like whips at the glass. You could hear it like shaking violently inside. And this reminds me of a tip. If you don't have the means to like put or the pieces too large to put in a kiln, you can also clean out the inside of the vessel, of the plasma vessel, by attaching a sacrificial electrode to it, filling it with oxygen, and running it for a while with a plasma driver. And oxygen plasma is going to decompose anything organic, is going to eat up and turn any carbon containing stuff, is going to turn it into carbon monoxide, carbon dioxide, and you're going to be able to pump it out. So it's going to be perfectly clean after a while. Then you tip off the sacrificial electrode and pump it down again and do the usual fill. Yeah, the blue one was nice. Yeah, it was condensed, very condensed stream of electrons. Yeah, here's another view of the Aurora tubes. An electron beam tube where you could move. It was like xenon in this tube, and you could move the discharge around and split it with a large neodymium magnet. Here's a neon that we've made, and this one is quite important for a reason, because the animated version of this will be somewhere down there. It was animated in such a way that the matador would throw the olives up, and they would drop in his hat. So they like lit up one after another. Typically, if you want an animated piece of neon, you're gonna need a separate power source for every section of tubing or a system, like couple of tubes. One group of tubes, but we came up with the idea of making a circuit board with vacuum high voltage switches, where you could power the neon with just one high voltage transformer. So that made neon, like animated neon, much cheaper, because power supplies. Neon transformers tend to be quite expensive. Oh yeah, here's a demonstrator of Bernoulli-Venturi effect that we made, working out nicely, like showing the difference of the pressure before, at, and after the constriction of a Venturi nozzle. We had Camila here carrying the water tank for that piece of the exhibition on her head in the elevator car with our electronics technician. because we needed to like build the whole thing, not just the glass. Just like I told you earlier, glass blower in my country needs to be a fabricator also, and sometimes it gets heavy on the fab side. Yeah, here it is filling up. Put in controller so it wouldn't overfill, and remember that electron beam tube that we saw earlier with the blue discharge and the mica phosphor covered mica sheet. We didn't phosphor coat it the usual way with the glue made of nitrocellulose and polyvinyl alcohol, because I didn't have the means to put it on the mica. I could like slather it on with a painting roller, but I ended up with too thick of a layer. So we ended up coating it the old way, making a flask with a round joint at the bottom where we could hook up a compressor and a stainless steel ladle and a piece of vinyl tubing leading to that kind of like smokestack made out of sewage pipe. Then you'd fill up the ladle with red phosphorus, set it alight, like plug it quickly, and blow into that. Actually, my business partner tried to blow on it with his mouth, and that was done. Pushing the smoke through the tube and through the improvised smokestack, where the piece of the phlogopite mica was hanging, in the like bathing in phosphorus oxide fumes. And phosphorus oxide exposed to atmospheric moisture turns sticky, and then I could phosphor coat it. It's actually an old way that old timer neon benders used to phosphor coat the tubing. Just they had the smaller version of that. Yeah, here's how it works, because that one was static, and here we can see how you'd be able to move it around. Kids would be able to move it around at the museum. Here's Wayne Stratman's tube. It ended up on the same exhibition. Yeah. Here are some more Crookes paddle wheel tubes. I never say no to my customers. Sometimes I have a general idea how to do something, but I don't know exactly how to do it. I end up experimenting and making a couple of test pieces first. So those are the test pieces. Some worked and some didn't want to budge. The final one came out quite vigorous. The funny thing is that the cupped electrode ends were made by Camila's colleague, who was a jeweler, and she made it out of like Polish currency, like small coins of Polish currency, like 20 grosz or 10 groshes coin, with the markings removed, and she used a jeweler's sponge to form a cup in it. Here's the animated neon, and the whole thing is powered. Yes. Here's the whole thing powered with only one transformer. And why was that important? At the moment that I designed that circuit board and used those vacuum high voltage switches for animating that neon, I had no idea that in some years I would be making vacuum pump down manifolds for the company manufacturing high voltage relays. So that's a funny story. Yeah, here's the Ruhmkorff induction coil power supply for that, and here we have the first ever single electrode plasma tube. It's actually a glass doodle made in like a couple of minutes, and filled with neon argon. Probably here, but it's the first. We probably still have it. The first single electrode in our workshop, and probably the first single electrode in Poland also. Here's what we powered it with. We knew nothing or almost nothing about powering plasma back then, so we ended up using an auto transformer, a ZVS driver, and an old car ignition coil, which ended up cooking badly after several minutes. We also do acrylic glass. Glass is glass. Acrylic is like organic glass is also glass. We needed to blow like hemispheres, or almost sort of hemispheres out of that to make large lenses, which then some of them were filled with water, and some of them were filled with water and immersed in air, and some were filled with air and immersed in water to show the differences in refraction in different media. Yeah, here's me, and here's Kamilka. As I've told you, I ended up working myself nearly to death while setting up the workshop. My colleagues wanted to cheer me up and made me into a unicorn. Yeah, here's another tube with snappy discharges, powered by Information Unlimited driver. Unfortunately, the owner isn't with us anymore, as you probably know. Yeah, here's me looking at the broken Stratman piece. I'm like, how am I gonna fix it? Yeah, here's some more snappy plasma arcing back to the manifold. Yeah, that one was pretty. That one was pretty. And very precisely administered minuscule amounts of nitrogen with the neon. Some more different plasma. The one on the bottom is iodine nitrogen. Spiraling blue thing. Yeah, is that one? We've seen this. We've seen this. This one's interesting. Here we can see a way, like the means to administer iodine or other halogens like bromine or chlorine to a plasma piece. We need to make a brake seal. You know how a brake seal is made. You've made some brake seals, like a thin capillary made into a zigzag, and then you have a small piece of an iron nail covered in glass, held by a magnet to the side of the tubing. And when you're ready to add the iodine, add the halogen, you can just shut the J. Young valve here and whack the seal with the magnet with that piece of iron inside, and heat up the ampule carefully to chase the iodine through the tube down to the plasma globe. Yeah, here's more of that. Here's the discharge that we ended up deciding on. It needed to be visible but soft, because the discharge travels the path of the greatest capacitance. And when you touch it, you are the path of the greatest capacitance. And like there's like a lot of children visiting the museum, and they like to stick small coins to the surface of the glass, or pieces of like aluminum foil, and they get zapped. So I needed to limit the current by the conductiveness of the gas mixture. So most of the energy would be liberated inside the globe and transformed into visible light, not ending up producing a ton of ozone around the globe, or zapping people too badly. Yeah. Here's here's an Archimedes thermometer. I'm filling globes with alcohol with food coloring added, and yeah, it was I needed to make a bath. The outer bath is made out of heated or cooled water, and the inner one was pure alcohol, because I needed to adjust the buoyancy of each of these pieces by putting it in the thermocycle bath and taking it out, removing minuscule, minute amounts of glass from the hook part with some emery cloth, so the buoyancy would stop at neutral, because that way we would have the buoy with the corresponding temperature floating in the middle of the thermometer when the liquid reached a certain temperature. It doesn't look big here. It was like 2.5 meters tall. Here's the whole display. The centerpiece is of course Wayne Stratton's piece. The small plasma globes were made by me. You can see the discharge very well because of the ambient lighting here. Some Geissler Plicker tubes, like spectral lamps, spectral tubes filled with single gases, to just like see what does a specific gas glow like. Here's the finished Aurora piece with the partial pressures and the mixtures adjusted to the point where they resembled Aurora discharge on corresponding heights given here in kilometers. Here's a vacuum. Here's a mercury discharge tube, because the museum bought some Chinese-made discharge tubes, but those didn't exhibit only the mercury spectrum. They were like all over the place, and I ended up replacing them with ones made in our shop. Here's our flat. At that time, we ended up remodeling both our workshop and our flat, and we were like left with no place to live. We lived for a year and a half at our workshop. So here's the place, like totally wrecked, everything torn down. You probably know Camilla's Laurel Reef. I'm sorry. A piece. In the green version, the final version, here it is being pumped to a different effect. We ended up quarreling, but the piece finally came out as a green snappy discharge. Here's my first plasma piece. I made it as a condenser and then decided to repurpose it into a plasma piece. I originally filled the inner spiral, condenser spiral with neon and the outer jacket with argon, but I ended up having a vacuum leak where the inner condenser spiral meets the jacket. I didn't have the means to like spark test it inside, so the gases ended up mixing over the course of next several hours and were like ended up as an argon glow. Oh, here's my doggo again. It's a lab wearing a lab coat, shedding lab coat in the lab. This is my workshop at the institute. A short time after I've taken the position of scientific glassblower. It was so ugly. Like everything was made out of yellow or brown particle board. I couldn't stand it. I ended up changing a lot of that furniture. Here's the only Polish-made glassblowing lathe that I know of, and probably the only one remaining physically, the only one remaining. We brought it in the Academy of Fine Arts like 15 minutes before our country went into shutdown for 2 years. So I just barely managed to drive it down there. We were hearing on the radio that like in an hour everything's gonna be shut down and we shouldn't be on the streets. We barely made it to the academy. This thing's interesting. It looks like a Herbie. Yeah, looks like a Herbie, but it's not a Herbie.
But it's a cake.
Well, kind of.
Looks like a cake.
This is an example of strive for excellence, because this is my well, not mine, because I didn't have a master. I didn't have the luck to have a master, to have a teacher. But this is my workshop's old master's torch. The story goes like this. Like over 40 years ago, when Poland was like behind the Iron Curtain and you couldn't get any kind of stuff of quality, especially glass blowing tools and torches. And he wanted the best torch that he knew about, so much that he ended up kind of sneaking one out, borrowing one secretly from a state-run company, and disassembling it with the help of his fellow machinist over the weekend, making blueprints, reassembling it, giving it back so no one noticed, and then he spent the next few months with his fellow machinist on fabricating like a dozen of those. They made a small mistake. It didn't have the candle feature, so they needed to add a small tube here, so it would so the torch would have a small flame to light from. But like they copied a Herbie. They made a quite a functional copy of a Herbie out of the desire for having a tool that would allow them to develop their skills further. Because before that they used to work on torches that ran on coal gas, very poisonous. Carbon monoxide, contagious carbon monoxide, other than being super poisonous, is flammable and is very calorific, and they used to run torches on it. They were giving large, wide, bushy, roaring flames, and they were like sick and tired of it and wanted silent torches, so they ended up making their own. Yeah, here's some more of making that birch, like a smaller version of that birch. Here's the Chinese tubing. Here's me at my humongous lathe. It's got the gearbox here. Like You don't have the auto transformer. You can hear it. You can hear it like switch gears. Oh, she wanted something like that. I made something like that. I would have made it prettier, but she wanted this. So she got this. Yeah, here's some more of that. Some more of the prep work. And that. Oh, and I've been setting up for that large final weld. And I thought it would go flawlessly. The thing cracked on me, and I needed to use all the firepower I had on the machine at the moment to melt it back in. And the alloy jacket was like hanging in the corner, laughing at me. If I knew, I would have like slathered some olive oil on myself and sprinkled myself with chicken spice. I would come out tasty because I was like completely fried. Yeah, here's the root part. Here's the moral part. Here we are setting up a temporary filling station at the institute to fill one of Camila's pieces. Oh, here's a cold trap. Oh, I also made this cold trap. The thing to remember about cold traps is that they need to be optically dense. You can't have an angle where you can see through the cold trap. And the space between the inner and outer jacket needs to be as small as practical, not as small as possible, but as small as practical. It's best to achieve it by pushing small shallow Marias, rings slightly protruding out of the inner vessel, to make the particles stick to the cryogenically cooled surface. Here we have a flask of nitrogen 15, an isotope of nitrogen, hooked up to the manifold. It was actually manufactured by the same factory. I found it in the institute's basement. It was manufactured by the same company that used to make the Rjukan works in Norway. They used to make heavy water for Adolf, and it was like from the same period of time. They somehow managed to keep it. It gives this translucent violet glow. But it ended up cracking, unfortunately. Opening that flask of the isotope of nitrogen was like opening a bottle of good champagne. Oh, yeah, here's the birch thing. Me repairing some kilns at the Academy of Fine Arts, because you guys here are respectful, are attentive. You like your professors. You like to work with glass, and you respect and keep the equipment well maintained. The campus is nice and everything. And at the academy, the professors are like, I'm like, what are you doing? You're gonna break the furnace. And they're like, I'm a professor. Who's gonna stop me? And they end up wrecking the elements, and then I had to repair them. Remake the quartz tubes, remake the heating elements. Yeah, here's another film that I'm fixing, ripping out the old spirals. Here's you've probably seen that one. It's called a sparkling column. It's not nearly as complicated as an Oldershaw column, but it was a fun piece to make. And you get a lot of satisfaction from making pieces like that, because this one was intended for research about redistilling tire rubber back into motor oil, and we're actually doing that now, because you can redistill rubber into motor oil, into some fractions of crude oil, and you can get the microcrystalline soot. The compound with which the rubber is filled and made more elastic, and it makes the rubber black. So they can reclaim the soot. and you can also reclaim the steel cord inside of the rubber tire. After you snip it into like inch-long pieces, it can be used as dispersed concrete reinforcement. So we make like a ton of waste turn into a lot of good and useful stuff again. Yeah, here's some more details. Yeah, and that would.
Did you drill all those holes?
No, fortunately not. Those are factory made. You can buy those, and those are pressed. The holes are like a bit conical. They were hot pressed and milled.
What do you call that apparatus?
It's a sparkling column. Yeah, well, that's about the end of the presentation. If you want to ask me something, I'll gladly try to answer your questions.
So that workshop that you built out, does that have some sort of affiliation with the business that you work for, or is that like your
No,
private
that was
studio?
that was our private workshop, and we had it like for well 4 years. 5 years, yeah. We ran it for 5 years, and then a large corporation, Deloitte, came in and bought the whole post-industrial complex, and they threw us out. I developed depression then, and we moved to the city of Wrocław, where I took the position of scientific glassblower, and Kamila started teaching at the Academy of Fine Arts, and now she runs artistic flame working shop. So like sometimes things occur that make you go like, no, I'm not gonna go through it, and that's what I thought back then. But here I am.
I got a question. Does the Academy of Fine Arts have any kind of, what's the word, or study abroad program?
We have the Erasmus Plus program, but that only works in Europe. I've spent the.
But we have some, but I'm not sure how it works, because right now I have the one student from Canada.
Yeah.
She somehow made it.
Okay.
Be a student, like a regular one. So we have a master degree in art, which is in English, but it is impossible to take only the class classes. You have to attend the whole painting, sculpting, and graphic and other stuff. This is somehow possible to come to us. But I don't know how.
And like I've spent the last 6 years working relentlessly to gather enough of scientific glassblowing equipment to equip a shop that would be good enough to teach, like to take in 2 or 3 apprentices at once. So I'm gonna be setting that shop up over the course of the next year. Like all the equipment is currently taking up space in the institute's corridors, in the basements, in people's offices and labs. They let me keep it there, but one day I'll have to remove it and bring it to the new workshop. And if I succeed with that, I'm gonna try to figure out some funding to bring people in from all over the world for like short residencies, like a 2 week long residencies, or some courses and classes. Because my apprentice Dominika, who currently works with Master Roswitha Krebs-Goldbecker, Klaus knows Roswitha very well. And Kamila's apprentice, Ula, are the first 2 examples of young glass blowers that were somehow taken care of and pushed out into the world. They were given the opportunity to take like foreign apprenticeships. So we didn't have that for the past 40 years. We didn't have any kind of scientific glass blowing teaching program. So we're trying to work around that as hard as we can.
Just like looking at all the stuff you showed us today, I'm like, is there anything that you can't do? It's like there's so many different.
Yeah, I absolutely can't dance.
And
I'm like petrified. I'm like stuck to the floor. Yeah, that I can't do.
And then
Okay,
speaking of that-
computer stuff. Like
I'm also a bit technologically impaired.
Like I just wonder, like, how do you become so good at, you know, being self-taught? Like it seems like you've taught yourself a bunch of different skills in a variety of different areas.
Yeah.
Could you talk about like maybe some of the failure that you came across too?
I'm autistic. I just have good medicines. Yeah, there's a lot of errors. There's a lot of there was a lot of errors. There was a path of blood, sweat, and tears. Actually, I'm just showing snippets of some stuff that worked out, came out pretty well. But yeah, the workshop, the whole workshop was I wasn't versed enough in like doing big business to be cautious enough and to not put as much work into that space and as much money into that space and as much time. Like I could do everything of that as a temporary thing, or like I have everything on casters to be able to move out and not lose too much when we had to empty that space. So yeah, that was one of the greatest mistakes, and I as I've told you, I have developed like heavy depression, and I'm like 6 years after. It's been 6 years since the old workshop collapsed. And I'm probably starting to heal just now from that, because that like cost me so much of my life energy. That was a huge failure. Now I'm wiser and I'm more cautious, and I know a lot more about doing business.
At what point did you realize, like, working 20 hours and sleeping 4 hours, like, how long were you doing
I ended
that?
up at the hospital. I ended up at the hospital, and I stayed quite a long time at the hospital. But there were signs before that. One funny thing. I don't know if I should talk about it, but okay, I'll tell you. Like after a whole day of work, I'm like sitting on a toilet, normal thing, and my brain like got cut off. I woke up falling on my face with like my arms and legs and anything not working. Like alarm lamps blinking and everything. My body trying to switch everything back on. I ended up like face planting on tiles from out of exhaustion. So yeah, there were signs. Yeah, I'm very stubborn. I'm very stubborn, and what drives me is what I tend to call the Kazakh factor. It's like if something is rad enough to pursue, I will pursue it, and I will succeed.
Any advice on how to take like your passions and skill sets and turning it into a sustainable lifestyle, I guess you could consider it?
Well, the career you all are pursuing is probably the best path, because I had a ton of different jobs. I had a ton of different jobs, and I ended up bored, unsatisfied, or they weren't giving me enough funding to support myself. And then I came across scientific glass blowing, and it's hard enough, it's interesting enough, it's fun enough to be keeping me on the edge, and it's done its job pretty well for the past over a decade, like 11 years. So yeah, I'd suggest sticking to scientific glass blowing, because you cannot get bored of that. There's sometimes something new. Even if you do like proto, I sometimes run into contracts where I have to. Oh, recently, I ordered like a small Edwards G3 lathe of Jeremy Bolton in Great Britain. Don't order anything from that guy. Like, it was a long established, trusted company, but they like something happened and they had to threaten him with legal action, or like taking a few days of my leave and arriving at his doorstep, so he would finally ship me my lathe. And I needed that machine to manufacture 3600 of transition seals from ordinary boro to 80 to 50 shot in 4 steps. And I ended up cranking that out by hand, because I've been waiting like 6 months for that lathe that I have ordered and paid for. So sometimes you have proto jobs which drive you nuts unless you can turn them into sort of a meditation. But then something interesting arrives. Some other piece of apparatus where you need to tie yourself into a pretzel to figure out how to make that happen. So you're probably on the right path now to turn your passions and skills into a living, and not dreading your 9 to 5 job for the rest of your life. That's probably the best place you could end up in.
That's great to hear.
Yeah, I've been hearing a lot of the opposite.
The one only school that I, other than Salem, that I would recommend is in the Netherlands. It's called the LIS, Leidse Instrumentmakerschole.
Is that where Katya is trying to get?
No, that's Norway. What Michal is referring to is the school I have been. They have a they train you not as a scientific glass blower originally. They train you as
A builder of
CNC,
all sorts of scientific apparatus.
CNC metal technician, and then they pick the glass. The glass teacher picks 6 students every year. So everybody goes through a whatever few week glass blowing basic skill, and then it says you're which I want to train, and then they become scientific glass blowers.
Yeah, and they have a pretty awesome program too. Like that's the only school other than Salem that actually teaches good scientific glass. So I believe you're in the right place.
Thank you.
See?
So
take advantage of
it. I think Paris, the school in Lycée d'Orléans in Paris, and school in Sweden are pretty okay as well.
Oh, yeah, the Twistle schools, and the Serraver. Yeah, the French. The French have weird ways of achieving the same stuff that we do. That's why. Yeah, like they don't use like graphite cones on handles for one thing. they have like plates with cones, and you heat up the tubing and you like make it wider vertically.
Huh.
So
Okay.
so unintuitive. They're like doing everything everything differently. The outcome is fine. They make their pieces with with great attention to aesthetics. Everything is rounded. Everything is like has fine proportions, and everything is melted in super fine. But the way they get to it is like super weird. So I'm not saying that it's a bad school of glass blowing. That's just not exactly the one I would like to attend.
Fair.
And you have to be
Do you use holders?
Do I use holders?
Yes.
Yes, I manufacture my own holders because I can't buy any grabbers or holders. Though I recently had my institution buy me J Behemoth two J Behemoth grabbers.
Oh, okay.
And I have two American made grabbers, and that's like the best piece of equipment in my shop currently. I make my own equipment. I make my own graphite tools. Recently, I've made some rollers. They came out pretty pretty sturdy and good looking. And I'm gonna donate them as the first prize in the competition at a flameworking symposium, Polish flameworking symposium that we're holding like 3 days after we get back to Poland.
Nice.
So yeah, you need to like you don't have torch manufacturers, you don't have equipment manufacturers in Poland. You have to figure it out and make it work yourself. Well, it makes it makes your days shorter, but makes your life more interesting.
On your cold trap, on your manifold, you said keep the wall spacing, or the
As close.
Is that to keep the
As close as practical, because I like to compare the particles in a vacuum system to ping pong balls, and the vacuum pump to a guy with a rocket trying to get rid of the balls, and like bouncing around in a random motion. And the more occasions they have to stick to a cryogenic surface, the better for the final vacuum. So you have to build cold traps in such a way that, like, if you had a, I don't know, liquid helium cooled straight piece of tubing, it would be a poor cold trap. It needs to have like a few bends or like a narrow slit for the gases to travel through, to be able to trap them. Like, you don't trap them forever. A cold trap only slows them down. They're flying off even off the cold trap surfaces. It just like slows down the rate of the outgassing and traps some of the gases temporarily. So the narrower and the colder and the more crooked, the better for a cold trap. But you need to the more bends, the bigger diameter it must be. Not to impair the flow rate.
That piece that you said had the most glass to metal seals that you've made before, you said that had to be graded with other glass on that piece?
That actually wasn't graded. That's why I made the whole piece. You'd normally make the whole body of a piece out of simple boro, like free, and make, if you had like one ferrule to attach, you'd make a graded seal and attach that ferrule. But since I had a lot of double barrel ferrules. I didn't have physically the space that the transitions would take up. I ended up coating the molybdenum ferrules just with the molybdenum glass, and then making the whole body out of molybdenum glass, and doing it that way. I didn't have enough space in that tube to fit the seals.
And I saw on that piece that there's like, it looked like there was a ground joint on the end too.
Yeah.
Did that have to be like specially ordered or made? in
No,
that
we make
specific
ground
glass?
joints. We make ground joints in the shop. We have what we call grinding stones, either made out of steel or cast iron or pig iron. You would call it pig iron. And for each size of a joint, we have a set of 3 stones, like a pre-grind, to coarsely shape it, a coarse grind and a fine grind. And after each use on the grinder, we need to take a pencil and mark it inside, because after like 5 uses, you need to take it back to the machining shop and redo the inner surface. Because like for joints that are used in pipes or in whatever, that's not as crucial. But for joints that are used for high vacuum, you need just a tiny layer of grease to be able to seal it. The way to test if a joint is tight enough when it's dry is to put it in liquid mercury, and if the mercury doesn't seep into the joint without the vacuum grease, then it's properly ground. Like no rocking whatsoever, no turning. Like if you stick it together, it kind of stays together. It's typically ground with a powder of like 8,000 granulation, 8,000, and then we have like champagne earth, fuller's earth, diatomaceous earth, polishing pink, to make it as smooth as possible. Yeah, there are just few shops that make joints that smooth, that need to make joints that smooth. But I hate the job. It used to be a punishment in the old days. Like if you were slow on the torch, you ended up grinding the joints. That's a nightmare. That's a nightmare. And your whole pink like up to here after the polisher's pink. You can't get it up. It's like gets in everywhere. You have pink fingernails.
Thanks.
Any more questions? They have a long ride to New York City.
Thanks a lot.
Well, yeah,
Yeah,
thank you very much.
Thanks for having me.
In April, there's the meeting of the Polish glass blowers, and in September, you're planning to go to the German symposium in September, or?
We would surely like to. I don't know if we'll manage, because I'm back ordered.
Oh. You can bring some of the stuff to the symposium and we can help you.
I don't do that typically, but I ended up kind of lying to some of my contractors to be able to come here, because I typically don't say no. If someone wants a piece of equipment, I end up like working at night or working over the weekend to make it happen. And they are kind of used to it. And now I have to say, no, you hold your horses, you guys. I need to go to the US.
Thank you very much.
Thank you.
I couldn't pass on such an opportunity.
Cool.